Thank you very much, Vish. As Vish says, I'm Stephen Smith. I don't like the James bit, but we incorporate that because there's another Stephen Smith in our company. In fact, when I started, there were about 12 Stephen Smiths in the company. So I use the James for differentiation. I'm working with Micro Focus at the moment, and often we tend to say Microsoft because we're also used to saying Microsoft, but it's not Microsoft, it's Micro Focus. And I'd just like to ask a show of hands. Does anybody know who Micro Focus is? It's exactly what I expected. Just about nobody does. So I'm going to start with a very quick introduction of Micro Focus and give you a bit of a picture. Today's session, I'm going to be a little bit more high level. I want to try and give you a bit of a bigger picture. I see a lot of the sessions today are going to be focused in-depth technical kind of things, and I want to try and show you a bigger part of the world and give you a bit of a vision like that. Now, we started more than 40 years ago with COBOL specifically. So COBOL was around on the mainframe those days, and contrary to popular opinion, neither the mainframe nor COBOL is dead. Did you know that? Definitely not. So everyone has, I'm sure, a smartphone, and everybody has on that smartphone some sort of a banking application. And if you're doing your banking application or transactions via that application, you will be touching COBOL code somewhere along the line. Okay? All the financial institutions, all the insurance institutions, core banking applications, etc., still run on COBOL. The COBOL code is growing. The lines of code in production is growing on each year, year by year, and so it continues. So what's effectively happened is Micro Focus has become the original app modernization company because we took COBOL off the mainframe, brought it onto distributed systems, and we've been keeping it up to date and modern up until this point in time. And that's what we are doing with all of these brands that you see along the way. These are acquisitions that we have made along the 40 plus years that we've been in existence. And so the effect of that is that we help existing customers with legacy applications keep their applications modern, up to date, fresh, new, etc. So for example, if any of your organizations are making use of our local partner here by the name of Sage for HR or payroll type applications, guess what? They're running our COBOL. And guess what? They've front-ended, we front-ended these applications with modern HTML5 type interfaces. So you don't need to use a 3270 green screen kind of a technology to interact with our applications. So we are doing that same thing with all the other acquisitions that we've made along the way. Now, I wanted to focus on how, from a Micro Focus point of view, we've started along the DevOps point of view, DevOps path, and how we've learned lessons along the way, what we've done, what we've learned, and share these with you that you might have some ideas to take back with you that perhaps you could implement along your paths. Because going DevOps, going Agile, these are journeys that are continual paths, and there are a lot of things to learn along the way. And I want to add a little bit to that in terms of how we're incorporating security. I thought that might be interesting to the process as well. Now, we started a number of years ago within our IT department, and one of the things for you to be aware of is, as Micro Focus is a software company, we have kind of two IT departments. We have the development side of the house, which is by far the greater part of the organization. And so probably more than 50% of our company, which is greater than 15,000 employees worldwide, are developers and involved in the R&D side. So we've got that side of the house, and then we've got the company's day-to-day business side of the world. And that is probably the area that most of you would be familiar with and working with. You're developing applications for businesses to make use of, either internally or third-party customers, and so that's where you are, spending most of your time. But we are also developing products. So you would see all of those brand names. We are developing products which we market around the world, and which we are bringing to the market. We used to in waterfall methods, and now we are moving more and more of them to DevOps style of process. So this is just to give you some numbers. Back in 2015, we had over 900 projects on the go. Most of these were in waterfall type of a mode, and we started with Scrum and Agile and these sorts of frameworks and approaches way back in the mid-2000s already. And it's been progressing from there ever since. We have hundreds of development teams. We've got data centers and main situations at certain places in the world, in the US and in Europe. And if you look at some of the numbers here, for example, we are literally doing thousands of builds per day. I don't know how many builds you guys do in your production lines or pre-prod or dev or QA environments, but ours adds up, and we have big numbers. So we've got big teams, a lot of people working at this, and a lot of lessons being learned in the process. Now, I love this quote from Gene Kim. I don't know if any of you have ever read the book called The Phoenix Project. If not, I do recommend it highly, where he talks about starting to implement DevOps practices in a IT department that's pretty much on flame, on fire, and chaotic, and how he starts bringing order into the whole environment throughout the book. So it's a very interesting read. I at least found it that way. And he said that DevOps adoption isn't mandatory, but then neither is survival. And we are finding this, I think, more and more. More and more companies are becoming software companies. The chap that gave the keynote was speaking about interesting responsibilities that comes along with that as far as we are concerned as software developers. Not that I'm a developer, but I work for a development company. So the mandate is still applicable. We have big companies that you would typically think of other, as a normal manufacturer, for example, Boeing and BMW, these types of manufacturers you'd see as airplane manufacturers and car manufacturers, but they are actually becoming software manufacturers as well, because those products that they make are extremely empowered by means of software, which needs to be tested and built along these kind of paths as well. So they're doing all these sorts of things in order to remain viable and remain up to date, contemporary with the market. If you as a new car buyer wanted to go and get something, you'd be looking for, has it got the Bluetooth capability? Does it integrate with my mobile phone, whichever that might be? How well does it help me navigate in strange places, etc. So, let's get more into what we, from a Micro Focus point of view, are doing and what it's changing within our organization. So if we look just at Agile and DevOps by themselves, as just for a brief moment in a simple view, we see that Agile was built to address, well, let's first of all talk about these walls. If we think of customers in the business on the one side, of development and IT in the middle, operations on the other end, there's typically these walls in between, silos or divisions. The one doesn't mix with the other, the one doesn't understand the other, the one hates the other. Yes? No? Not in your organizations? No? Well, in ours. So Agile was really developed intending to break this wall down over here between business and development, and DevOps to break the wall down between development and operations. At least that's the theory. Now, one of the systems we built a while back within Micro Focus actually originated on the HP side of things. That was one of the acquisitions that Micro Focus made, which was concluded about a year and a half, going for 2 years ago now, where the whole HP software division was bought lock, stock and barrel into Micro Focus. And there we had a fraud detection type of application, which took us quite a while to develop. But some of the points over here highlight some of the improvements that we've made to that particular application by taking an Agile and a DevOps approach to it. And one of the interesting ones I'll just point out over here is that internally we did surveys in terms of rating the company in all sorts of metrics, and this was one of the ones that improved as a result of this particular undertaking that we did. When we started off with this process, this is a picture taken from the actual room. This chap there in the back corner was the CIO at the time. He got a bunch of people together from all the disciplines. So there were not just developers over there. There was operations guys, there was architects, there were auditors, there was security, there was business, there was everyone that had a stake. And they started out just trying to understand, what is this Agile thing that we are doing? What is this DevOps thing? What does it mean to us? What are the implications, etc.? Just initially trying to get a fundamental understanding of what is this undertaking that we are about to get underway. And the first thing that they really did was come up with a manifesto, which I share with you over here, with 7 points that really outlined the way they understood what they were undertaking or embarking on at that point in time. Noted it down and made it available to everybody, so we use this as a guideline. So, for example, we formulate hypotheses, we validate them with experience and data. So, in other words, we take a guess, and then we measure how accurate this guess actually is after implementing it and going along a little way. Some major changes over here, really cultural and organizational. For example, with trust, we value trust and responsibility. That was a very painful one actually to undertake because companies by nature are very careful about who they give control to, and letting go of control is a very unnatural thing. Any one of you a parent? Yeah, some parents over here. So your little baby is born and it's totally dependent on you. And your job as a parent over time is to give more and more control over to that little baby. You enable him, first of all, to take control, but the giving over it and giving away of that control for a parent is a tough job. I know about it because I've raised 4 kids. So companies go through the same challenge. And in so doing, we also looked at other information out there and available from the industry, like Gartner, for example, uses this for metrics. And we used some of these metrics that they suggest we look at to measure our effectiveness and how we are doing as far as this is concerned. So what changed? What was different along the way? As I mentioned, first of all, the command and control. I'll elaborate on each of these as we go along, but I'll start first over here with the command and control. What we did effectively was we integrated teams across silos and we made them empowered. In other words, we gave them responsibility from one end to the other of the team for the application or service that they were delivering. So from the business end to the operational end, and everybody in between was given responsibility for particular projects. Now, I'm using this to illustrate the difference between flexible systems and rigid systems. Guess which one is rigid? Well, it says over there, doesn't it? So, stupid question. So this is what happens when you have a rigid command and control type of a structure in place, but the world around you is wobbling and changing and flexing. Okay, you have to be able to adapt. And if you don't, you're going to end up falling apart and breaking apart, as we see on the right-hand side over there. A similar principle really is applicable to the organizational changes that we made. All right, so why don't you want to go? The biggest part of the change was around the culture. So ownership of the projects, of the applications, of the services that we were delivering. Remember the first slide up ahead there, 900 different projects that we had on the go. Autonomy around each one of those, taking that away from the business and giving it to the teams, and driving them in terms of business outcomes. So making them responsibility for the business outcome behind that particular project. And this is one of the most important points, I think, that we need to decide upon whether or not it's the right thing for us to do in terms of going ahead with a DevOps kind of approach. Is there a proper business reason behind this? Because if there isn't, you're going to fail. If there is, we're going to succeed. On the technical side of things, we built a number of pipelines. I'll be explaining more about that in the next few slides. But the smaller circle there denotes that it was the easier of the challenges. People make the tools and the pipelines the big thing. Look at solutions out there in the market and decide this one is better than that one and we're going to use this. That's kind of a much smaller discussion and set of changes that needs to be made. This is the big challenge of the culture. So either my battery's gone flat or something's gone wrong. So the company letting go of their total control and entrusting that to the different projects was the one thing that we did. And we came up with the term minimum viable process. You've probably heard of minimum viable product, where we start out with agile programs. This is the minimum that we need in this product that we're trying to create before we can get it out to market. Well, same applied to the process. So that picture that I showed you earlier of the team getting together, one of the tasks was to analyze everything that we did. Ask why a number of times to really understand whether or not what is being done is useful, but how can we improve it? And how can we get that geared towards the system? So, probably one of the biggest pains in your life as well is a request for change. Something happens with the application, either you want to add a new feature to it or update it, or maybe something's broken in it that you need to fix, which at the end means you need to make some sort of a change to the code that's in production, and you can't just go and do that. There's probably an RFC process, right? And there's this big organization, probably in your company, called the Change Advisory Board. And you've got to, I see a lot of these things. So you feel the same pain, eh? These change advisory boards are more like, how can we become a roadblock in how many different ways? It's just no all the time. And one of the things that they want is records, requests, signing offs, meetings, all sorts of nonsense. But when we looked at the pipelines and what they actually consisted of and how they worked, we found that along the way, first of all, from the deployment side, if you have everything as code, that's already one record, isn't it? We are already keeping the application, everything as code, in our Git repositories or whatever it is that we're using. Our environments as well, everybody's going virtualization these days. Are they not? And that's no longer good enough. We're talking containerization, which makes the problem even worse in some ways. But that is as code. We can define data as code. We can use code to create our data sets. And we can define infrastructure as code. So everything as code is already over there. This can become part of a change record. So when we run an automated process, it logs when it ran, what it did, what the outputs were, etc. And so when we showed that to the auditing people and to these cab type people, these bean counters, we satisfied them as to the requirements that they wanted to see from all of these changes that we were proposing to automate down through the pipeline. So one of the principles we used in this process of changing the culture is something we call pain. You know, pain, when you hurt. We all hurt when we got to go through a change advisory board, and when we got to fill out papers, and when we got to attend meetings and all these sorts of things. It's a fat pain, and it takes ages. So we gave this to the teams, and we said, okay, you either use that process, or if you want to make some changes to production, it's got to start at the beginning of the pipeline, and everything through the pipeline has got to be automated. And the only way to make a change in the production environment is through the pipeline. So the pipeline only has root access into deployments into the production environment, and those are your two options. Pain-free, painful. Pick your choice. Guess what they chose? So more and more, well, they didn't all choose that. We started with 8 specific applications initially as our unicorn type projects, and then that started expanding, and it's been expanding then more and more ever since. And we looked at those applications, and we determined, we first analyzed to see which would be the most suited from those 900 plus that we mentioned originally, to going an agile, not waterfall, agile DevOps type of approach. So what did the teams look like? How big were they? How suitable was the particular project moving from a waterfall type approach to an agile approach? In other words, could backlogs work? Could we use our customers to actually determine the priority on these backlogs, etc.? There are a lot of questions we asked like that, and that helped us narrow them down to those 8 that we started off with. So, where previously everything was manual, we moved to automating as much as possible. So coming back to the everything as code. Not only the application, but everything around that as well. So the environment, the configuration of the environment, the data to be used with the application, the infrastructure. We've mentioned these already. The nice thing with creating this as code means that you can start automating deployment of each of these aspects, recording each of these, version controlling them. So all of this can be tracked and stored within the code repositories that you're already making use of. So an expansion of their capability over there. Okay. So one of the things we also realize is that the goal of the CD pipeline is to eliminate bad changes and promote good changes. Before we even get to that though, this is the process that we use from a company perspective to actually look at not only our own business apps that we make use of internally, but also the applications that we provide out to the market over there. So, for example, we have a number of products around COBOL that I mentioned earlier that enable us, for example, to take COBOL code off the mainframe and run it on your laptop. Okay? Test it on your laptop. Make sure it's all working, and then when it's done, deploy it on the mainframe and run it over there. Right? So, how do we update that? What do we do? That all comes into an analysis phase over here at first. So from a high-level company perspective, the CIO and the CEO, actually more the CEO and his cohorts, look at budgets, how much they're going to give to R&D, how much each team is going to get, etc. And of course, there's a number of business KPIs that they look into before making those allocations. But that all starts happening over here. They look at the portfolio and they want to understand how well is it doing. Well, guess what? We're still investing in COBOL, so that tells you that COBOL is still alive and well and growing out there around the world, as an example. We capture demand from all over the world as far as, let's take COBOL again, is concerned, as far as that's concerned. And so there'll be all sorts of requirements, enhancement requests, etc., coming from our customer base all around the world. And these need to be prioritized. So that all gets done, and then we go through the final decision phase, and then really is where, in the development side, where we kick off the projects, and we give them the go-ahead, we tell them how much budget they got, what approach they're going to take, they decide, etc. And eventually we get something that we can release either out to the market or to be consumed internally. So that would be really the first stage of what we're doing. Then I mentioned the pipeline. So we've built this CI/CD pipeline. And along the way, there are a number of things that get done. A couple of things we made mandatory, but the rest we left up to the teams. The one thing that we made mandatory was everything needs to be in a version control system. And for us, we decided to use GitHub Enterprise. And we still use that. So that's the first mandatory thing. The last one was pumping it out into the real world over there on the right-hand side. It needed to be done by the tools, which needed root access to the environment. No hands-on, no people doing manual deployments, nothing. Those were the only two mandatory things. So this plethora of tools that we show symbols for down below over here, we left up to the teams to decide what they want to do. Another guidance we gave was, for example, with Gerrit and or Jenkins, the size of the teams and the amount of code, the lines of code and amount of changes we used as a differentiated between the one and the other. So this pipeline, first of all, the ownership of the pipeline was given to the team. And the team consisted of individuals from business, development, architecture, security, auditing, QA, the whole bank shoot, all the way into the operational side. So your DBAs, your different OS people, your architectural side, your networking side. Everybody had representation in the team, and everybody had a role to play and a responsibility. And so this whole team was responsible for everything throughout the whole pipeline. Okay, so no more silos, no more I'm just responsible for the database, and I don't care about whatever else you're doing over there. Everybody is responsible for everything. And anybody along the pipeline has the ability to stop the pipeline. Okay, that's a principle we took from Toyota. The Toyota production line is a long production line, and everybody on the production line is responsible for QA. And if they see a problem, there's a long chain from the roof they can pull, it stops the whole production line. Everybody gets eyes on the problem, decides what needs to be done to fix it, fixes it, and then we get the production line going again. There's no, in this production line, this is our software production line, the direction of it should be this blue arrow, not the white arrow. Okay, the white arrow should just be feedback. We shouldn't have cars coming back this way up the production line because a previous stage an error or some sort of a breakage was introduced. No, we've got to get everything flowing in one direction. So, some of the principles that we did. So, I mentioned version control. Peer-reviewed, I kind of touched on. Automated tests all over the show. Functional, performance, security, and I'll elaborate a bit more on the security in a few slides along the way. Gates all along the way as well. Again, the people looking at the whole process, they actuate these gates and determine whether or not this continues. We've spoken about automated deployment. Feedback, not so much, but we've built into all of these tools the capability to provide feedback to the whole team. And I'll talk a bit more about that, how we've done that in a couple of slides. Okay, and then out into the operational environment done by the tools, the deployment tools. And so that's what we have. Changes, moving, and not stopping, well, sometimes we stop, yes, but not moving back in the other direction. Okay, now, how did we go about adding security to this? So, when we start developing, the problem with security is that I presume just about all of you, if not all of you, are developers, right? And when you did your development training, did anybody actually specifically teach you about coding in secure methods? Everybody's going like this. I don't see anybody saying positively nodded. Okay, I expected that. So that's the problem over here, because we start writing our code, but we're not necessarily creating it in a secure way. And that's where we need to fix it, because this is where we are introducing the security defects by writing code insecurely. So what we start doing is, from the development workstation, we have plugins into the IDEs that actually, almost like a spell checker, assist with identifying potential vulnerabilities to the developer. Drawing a little squiggly line underneath the offending code and explaining to the development person what exactly the problem is over there. Giving them an example of bad code, giving them an example of good code. So sort of on-the-job training almost of how to do this better. Okay, so that's one aspect. Another one would be using what we call source code analysis to actually scan through all the code. We need that because each developer, you work on your little unit or whatever component is you're busy building, right? But you're part of a bigger team, and we're all checking out and checking code in to a common repository. And we're all doing different things. And we're building a collection of files together that's ultimately going to be combined and built into my final product at the end of the day. Now, all of that needs to be scanned. And we need to look at not only the bits and pieces that you've written, but potentially any third-party libraries that might be incorporated into the project as well. Like the previous speaker was talking about, many different ways of bundling these things into these projects. Then it's going to go through to the build system, and the build system is going to bring all the bits and pieces together, create an installable package that can be deployed to somewhere, be it on a server, be it on a VM, be it on a mobile device, whatever the case might be. So, along each of these ways, we actually scan code and we do some security testing against them. So the first kind of scan we do is what we call SAST, or static analysis software testing, and another one we call DAST, dynamic analysis software testing. The difference between the two is the one we look at the source code, the other one we actually look at the running code. So almost black box kind of testing. Get it up and running, and then we try and hack it. So it's almost like an automated pen test tool or tools that we use to hack this code. And this is all done before it actually gets out into production. Okay? Now, if we find some sort of issues along the way, we, along the further paths, and let me just build this out all the way. Those need to be treated just like any other vulnerability or defect will be treated. Okay, well, let me say rather defect, because we're used to dealing with defects, don't you? You use your wonderful Bugzillas or Jiras or whatever to log these defects, don't you? Right, you're fastidious about using these tools, aren't you? You just love using them, don't you? You're supposed to do this, not this. But I know you do this because you all hate them. It's an interesting challenge from a management point of view, but that's a different topic for discussion. So we find these, we log them, we bring them back into the logging tools so that management can see what's happening. We want to build up a security perspective of the environment, not just a functional and performance type perspective of it. And we manage it just as though we were managing any other sort of a defect. So go back to the developer, let him fix his code. Problem is going to be he doesn't know how to fix the code. So incorporated into the tools are, as I explained earlier, ways and means that we can actually help. First of all, show the developer the exact lines, the offending lines, what is wrong, all sorts of documentation around these horrible things like SQL injections and cross-site scriptings and all sorts of weird and wonderful hacks that are out there, which you may or may not understand. Most of you don't understand it initially, but we explain that, or the tools point that out to our developers, and so they pick up speed along the way. And the idea is that next time, they're not going to create the same vulnerability or defect. So it's a continuous process. Now, when we do the static analysis, there's actually a three-phase flow that we go through. The first is we translate the code. So if you look at the market out there, there are various tools that do static code analysis, but they don't support all languages. They work with an internal normalized syntax tree that they understand, and they need something that translates that language to the tree that we work with. So if we're creating a Java application, we did translate that to our internal app, or COBOL, or whatever, doesn't matter. So that's the first phase that we do over here, is we translate that code to this intermediate model, and then we start analyzing this model. And when we do this analysis, we are just looking at how is this application put together, what are my control paths, what are my data paths, where are my inputs, where are my outputs, am I using buffers, what do they look like, etc. And then we go through what we call the audit phase, and that is we actually test the application as from this perspective. So I mentioned the normalized syntax tree. We create these files and we run our analyses on these. And these are the 6 or 7 different things that we do. So we look at semantics, we look at the structure, we look at the data flow through that, we look at the control flow through that. And these two are especially interesting because what we do is we introduce taints. A taint. And we'll understand what the word taint means. So if you were to paint a picture, for example, if you tainted it some way, you dirtied it, it's not nice. So we do something into that code, and we want to see what happens with that particular taint. Does it pass through? Does the code actually resist this taint? Okay? And if it doesn't, well, then we have a potential vulnerability over there. So these are some of the things that we do over there. We look at the buffers, we look at the content, we look at the configurations. People do silly things in configuration files, like they hard code passwords, etc. Laugh, they do it. Maybe there's some guilty laughs that I'm hearing over there. Yeah. Okay. So clearly, not a good thing to do. So we look for all of these things. And having implemented this is one of the things that we did. They are now no longer allowed to wear this particular T-shirt. Okay, so the idea is that we've built these pipelines. We want to reduce the friction. We want to get changes flowing through it as easily and quickly as possible. We either use GitHub pulls directly, or we use Geratin in conjunction with that, depending on the size of the team and the amount of change that we're looking at. And we find ourselves moving, should have probably done it the other way around, from a more waterfall type, not that regular release, to a much more regular release kind of process, and where our MTTRs, mean time to release, etc., are becoming a lot shorter. That becomes important because that is a measure for business that you can give to business to show them how much of a business partner you are becoming to them. Because in the past, they would come to you with a request, and you would say, this project's going to take 18 to 24 months and it's going to cost us so much. And that's not acceptable to business anymore, especially in today's environment. If we have now I laugh at my previous speaker over here because he said the 4 most hated words that a developer could want to hear. He says, I have an idea. The product owner comes to you, I have an idea. And you go, oh, shit. Okay? So that's what these user stories up at the top are over there. I have an idea moments, and they want to get that out as quickly as possible. So if we can change that down from months to days, then we are a lot more relevant to them and a lot more helpful to them. So in terms of our environment, I thought it might be interesting for you to have a look at how we've built our environment. So these are all different sorts of technologies and basic architectures that we're making use of. So we build cloud-native applications. We have various either hardware or other virtualized type technologies that they rest on top of. Of course, we've got a lot of legacy apps in the environment. We're moving those, or have moved them, from dedicated hardware to virtual machines. And of course now containers are the flavor of the day, and that's actually resulting in massive amounts of deployments to our environment, and instead of them lasting for a long time like this side would, it's lasting, hours, maybe minutes on that side of the house. And so we need tools around this side that actually helps us manage the sprawl that is taking place over there. So therefore, when we talk about this, the operational side, the architectural side of the guys need to be involved up front, early, to know what is the technology that we're looking to make use of, and how well prepared are they to actually cater and provide for these sorts of things. So do they have enough disk space or memory space or CPU cycles or whatever it is that will be needed to actually run these particular applications down that side? And what tools are they making use of? So I like this one because it'll give you a bit of a better feel for what's actually going on behind the scenes. So if you went to our website, you would see something like that. It's not that, but it would look something like that. Okay. And there will be many different product lines, and in those product lines, different products. Okay. Underneath that, we are using service broking type technology based on IT for IT. I'm not sure if any of you have heard of IT for IT. You probably have heard of TOGAF though. Okay, so architectural framework from the Open Group, which is TOG, which is where TOGAF comes from. Now they are also formalizing and publishing this particular IT for IT standard. And underneath that, we have all of these different, we call them service providers, and they would be backing up what is shown at the front of the page over there. But they're almost all different autonomous kind of systems coming together collectively to provide this holistic service to us, either from an internal perspective or from the products that we deliver out to the market. I've overspent my time already. So quickly, we also employed something we call ChatOps. Now, ChatOps is really what we've used to break down the barriers between the different divisions, different environments of the company. And so we've built chat rooms where we not only put people on, we have different rooms. Each room that you see over here belongs to a particular app, and there are the people and or bots that are participating on it. I think somebody's showing me my time's up. And then we see discussions, and we see report backs and inboxes and all sorts of things. So just a quick view, these aren't going to take long. We have augmented this for DevOps. So we, in other words, built this chat room. Everybody in the project has a view of this, and this is the way we give everybody eyes on the production line. So if a build is running in Jenkins and it fails, Jenkins tells us in this chat room. If I want to get some report from this, I can actually run a command. So, for example, my colleague over here wanted some status for a particular API. He got a response from a particular host that was hosting it, okay, via the bot. If my other colleague wanted to see what the server load was for a particular database over the last 2 days, he just ran that, and it told him what it looked like. So we can do this. We can include social as well. So the one particular project, they got all excited about Docker and did some funny things over there. So it works over there as well. Yes, we work differently. The result of this has meant that if you look at these measurements that we've measured over here, the height of the line indicates the amount of time against a particular function. So deploying changes, you can see we've reduced the amount of time. Infrastructure management, well, or writing scripts, obviously we're doing automation, so creating of scripts is going to take more time. Less time for infrastructure management, but we can see over here significantly less time for meetings or for support or for firefighting and so on. So when management looks at these sorts of things, they see positive benefits as a result flowing from the efforts that we've gone to move to a DevOps type of a world. So in summary, these are the kind of things. So we've moved over the last 6 years, 6 or more years, from starting out with 8 products to 35 plus that are in this, and it's a continuously growing number. Our major release cycle, especially for the products that we release out to market, used to be 18 to 24 months. Now we're doing monthly and quarterly type releases on them. Especially on the SAST platforms, we are doing monthly releases. In fact, there's even weekly things happening underneath the hood there for those that pay attention carefully. So build to QA, we would do every 2 to 4 weeks. Now it's a continuous thing. Okay, a developer does a checkout, he checks his change back in, immediately a build is executed, is tested, we run automated tests against that build, and we report back so that that developer knows whether or not he's broken the build. We don't get a whole bunch of developers first collecting all of their changes and then submitting it and then testing it. We've done that, and then we find, well, who's the one to blame? So that's also, I mustn't talk about that because I haven't any more time. But you've got to move away from the blame culture. You've got to get the notion of it's better that I find out my mistake sooner so that I can fix it sooner so we can get things running up and in production sooner. And everybody learns from the process. So yes, initially it is very intimidating for the developers to accept that, but there is definite benefit for that. Okay, so that is me. Hopefully you've learned something from my few thoughts I've shared with you that you can take home. Thank you very much for attending. Any questions? I will be outside. Thank you.